Hello, everyone. And if you were not aware, this was officially UCF's Space U Week. For literally the last week, our websites, anything UCF related, has actually been labeled Space U. And, why are we doing this? Well, UCF has a very long-standing tradition associated with America's space industry. We were founded back in 1963, primarily because the location of the university is about a 40-minute drive to the physical Kennedy Space Center. And so UCF, which used to be actually called Florida Technological University, was founded to support America's burgeoning space program. So we have a really cool history that we are very, very proud of. And through Space Week, we take time and opportunity to bring together students, PhDs, researchers who are all doing incredible work to continue supporting America's space program, which has gone from primarily a government-run program through NASA, right, the National Aeronautics and Space Administration, which is also, again, 40 minutes away from UCF's campus. But we are now becoming, the Space Coast is becoming the world's hotspot for commercial space enterprises, hence the reason SpaceX has built literally 2 football fields worth of buildings. Blue Origin, the same thing. So we are very fortunate. Our proximity to all of the incredible space industry development, and it's just, the continuing tradition of everything here at UCF. So again, hope you had a great Space Week, and it's not over yet. Tonight is the Space U game between the University of Houston, and we also have a tailgate that's happening. So like I said, big exciting week, and in the future, be sure and take part of the activities that are happening. All right, today's final department lecture is the Materials Science and Engineering Department, and very excited to talk about that today. You've done your module work, so you have basically a pretty good solid idea of what materials science and engineering is all about. It's primarily, materials scientists look at the structure of materials on a atomic level. And then materials engineers take those materials and actually create products that, are very valuable to society. Material science can be kind of summarized, believe it or not, with the following diagram that you see on the screen now. Basically, material scientists of all types look at the structure, the properties, and the processing of materials, with the ultimate goal of looking at the performance of that material. So let's talk real quickly about that. The example that we're going to use today is SiO2, silicon dioxide. Basically, silica is a material with the structure, unique structure that you see there. All right, so again, step one for every material science engineer is you look at the structural properties of the element or of the material. Next step is you have to identify all of the unique properties of this material. For example, here again, silica is it's something that has a very good thermal insulation properties, and it also can retain heat for a long period of time. It takes a longer time really for the heat to transfer over. The example of the processing, the property that we were looking at was that basically, absorbing heat. This item right here is an actual insulating tile that was on the underbelly of America's space shuttle fleet. You can see even on my jersey, which was from 2021, and it was to honor the space shuttle program. Each of these tiles that were on the underbelly of the space shuttle were individually identified, individually tested. There were specification sheets and qualification sheets set for every single tile on every single of the 5 shuttle vehicles. So again, the properties of that lent itself to being the silica being processed into that thermal coating. And you can see again how the tiles were created. It's literally just kind of a foam type material with that silica coating. And then you see the final result is the the launch of the space shuttle. And these tiles superheat. They literally would turn red upon the vehicle's reentry into the Earth's atmosphere. So to summarize, understanding, optimizing a material's structures, the properties, understanding those, and then knowing how to process that material is what material science and engineers do, because they want to get the optimal performance out of a material and make applications throughout all engineering disciplines. Right now I am in Engineering Building 1 outside of Suite 207, which is the suite for the Material Science and Engineering Department. Want to let everyone know that you can get, obviously, a Bachelor's of Science degree in Material Science Engineering. You can also minor in Material Science Engineering, which I think would be a very exciting and interesting minor to consider for everyone. They also offer our accelerated BS to MS program, so you can earn graduate credits and graduate coursework as an undergraduate in material science and engineering. And then, of course, we wrap out the programs that are offered by them in a Master's of Material Science and, of course, a PhD as well. And the faculty here in the Material Science Department, they are just some of the most just interesting, hardworking, kindest faculty members that I've really had the opportunity to work with. They've got 30 or more PhDs from all over the country. That's another unique thing about this department, is that it's just such a blend of people with different backgrounds. They have backgrounds in physics, they have backgrounds in electrical engineering, and of course material science and engineering. Many highly respected individuals from the national and international organizations of material science and engineering as well. And one of the really, I think, very much a selling point for a degree in material science is the fact that this department is just very close-knit. The student ratio back in at least 2024, when I collected this information, was 4.16 students per teacher in your classes for material science. And that to me is fascinating, because we are the second largest public university in the world, I mean in the United States. So, for you to have that small classroom size and interaction is really a big plus for this degree here in the College of Engineering. So look at this slide. What's your backpack going to look like? Well, hopefully you are going to be interested in chemistry and be very comfortable with that subject. But again, the PhDs from this program, physics is another forte area of theirs, as well as, like I mentioned, electrical engineering as well. One of the biggest selling points for material science engineering is the fact that earning a degree in this field, you will do collaborative work. I mean, it's almost like the world is your oyster. If you are interested in a space program, you can use your material science degree in the space program. If you are interested in, automotive industry, same thing. Interested even in the environment, renewable energy, all of the solar cells and all the materials used for that, you can see it impacts every different field of engineering. So along that line, this next slide showing you all of the many companies that you can apply to. This is where our grads have received, employment, and you can see from that diagram so many different and diverse companies. So again, want to just recommend that if you are interested, to come on down to Engineering 1, room 207, and just connect with this department and find out if this is the major for you. Take care, everybody, and happy Space Week.
Hello, my name is Dr. Mitchell, and I am an associate professor at the University of Central Florida in the Materials Science and Engineering Department. I came from industry, where I worked in aerospace and industrial gas turbines and Oak Ridge National Laboratory, and I've been at UCF for about a year. And I came to UCF to teach because it really is a great fit for my background in developing advanced materials for hypersonic and space vehicles.
Dr. Mitchell, with your experience in industry, you probably have insight regarding why students should consider material science and engineering as a major and a future career.
Absolutely. To me, material science is a critical technology. It sits right in the middle of all of the fundamental sciences of chemistry and physics, and even the more practical engineerings like mechanical and aerospace. And it takes those and moves them into a product. The materials are really what make things work. So knowing the fundamental nature of materials is critical to translate almost any fundamental idea into an actual operating product or vehicle or space vehicle.
Can you maybe tell us why you chose UCF and what you are doing soon in your research labs?
Yes, so most of what I've done over my career has been to advance the state of science in those high temperature materials like the space shuttle needs to re-enter. And so I was performing more of that research at Oak Ridge, and the University of Central Florida started what's called the Hypersonics Center of Excellence for Space Propulsion. And so I was one of the hires for that center as the material science person in order to create those materials and research and develop even more advanced materials so that hypersonic vehicles can go up to Mach 10 and be able to survive. And so my research really focuses around additive manufacturing, advanced manufacturing, and creating these new materials that can help us go faster.
Oh, that's incredible. It fits perfectly with our Space U theme and efforts. Also, the research that you're doing, I understand your lab is currently in the works, right, being developed. And where will it be located?
Yes, actually, we have a building that has been retrofitted. There's going to be about 6 professors there. Dr. Kareem Ahmed is there now in the propulsion side of things. My lab will be built there, which will be a ceramic and composite fabrication development lab. And then we have several other professors that will also be in there, all of us focused on creating advanced hypersonic vehicles for the nation.
And that is the facility, UCF's new hypersonic facility in Research Park?
It's called Hyperspace, and it's in Research Park, yes.
Awesome. Well, in the future then, will you likely have opportunities for our students to do undergraduate research?
I absolutely will. I currently have a PhD student and 3 undergraduates volunteering for my lab to help me build the lab. My team will continue to grow with more graduate students and more undergraduate students as I continue to evolve the program.
That is incredible. Well, let's keep in touch so I can let the students know when you have some opportunities available. Thank you very much for your time.
Thank you.
Hi, everyone. My name is Victoria Shautzova, and I just joined this fall our wonderful Department of Material Science and Engineering. And even though I've done in the past electrical engineering degree for my undergrad in Belarus, actually, where I'm from, and after that I moved into physics, so I did my PhD in physics at Imperial College London, but I really realized that my true passion is materials and what happens with them. And because of that, I moved to Oxford University to study materials for my postdoctoral training, and I stayed with materials department at Stanford for the last 4 years as well. And now I'm so excited to be here and be part of our materials science. And I hope to convince you today that materials science is the way to go.
So you might be wondering why you have to join material science. Well, the very straightforward answer is that because it's interdisciplinary. It's not just materials. What we do, we touch on all disciplines. You might be doing nanochemistry, you might be doing, of course, materials characterization, but then we also make applications out of it. We make electronics out of it. We make biomedical devices out of it. And then, of course, we study physics to understand what's exactly going on there, to understand our devices and prototype them better. So as a result, you become really experienced in a lot of different areas to the point that you can draw a picture on a piece of paper and create it yourself fully. And because of that, of course, you're really wanted and desired in a lot of companies. And because materials are all around you and it touch everything starting from electronics all the way up to like airplanes. You can choose from whatever industry you want. You can even do biomedical. And right now is probably one of the best times to do that because there are so many job openings in places like Apple or Meta or in places like Lockheed Martin, for example, or Boeing. So you can find whatever you want and whatever your soul desires.
Since you started this semester at UCF, I know you've been very busy preparing curriculum so you can actually teach in the classrooms next semester in the spring. But I hear that you're also very busy getting a lab up and running. Could you please tell us all about your research and the opportunities that might be out there for our young undergraduate students?
Yeah, of course, with great pleasure. My research, as some of other faculties in our department, focuses on the field of nanotechnologies. For those who don't know what it is, this is everything about nano objects. So we are looking at all the interesting properties of these materials when you start reducing their size. So in the normal world, you typically interact with the systems which are millimeter large. So like this pen, for example. But if you take a materials crystal, which is a millimeter large, and then you start shrinking it down, the properties change a lot. And this is exactly what we do in my lab. We study the materials which are only single atomic layers thick. And yes, we take the crystal and we strip off a single atomic layer, thin layers, and then we make the devices out of them. And what's really fascinating about this field that for a very long time, people actually believed that these materials will not exist and they cannot be stable. So the first demonstration was only in 2004, and it was followed by a Nobel Prize in 2010. And by now, these materials became so important for electronics and for potential applications that we have like a huge library of them, and we're capable of growing them on large wafers. So nowadays, what we are prototyping and testing is real electronics for potential applications out there. And what's super interesting about them that you can take one layer at a time and stack them on top of each other. And in that way, you can create almost like a Lego block of whatever you want. It's almost like a sandwich that you create. But this sandwich is very, very flexible because you're working with a single atomic layer thick material. And because of that, you can actually take such a sandwich and put it on a flexible substrate, such as the one that you see over here. And why do we need those flexible substrates? Well, we actually need them if we want to connect to a brain, for example. And this flexible system, as you can see floating here inside of this tube, this is exactly the one that people use in Neuralink to connect to the human brain right now. This is identical material system, and that's why it's so flimsy and so flexible, as you can see here, because we're trying to connect to a jelly-like brain, basically. But this is where our nanoscale materials can really shine, because this is exactly matches their properties. They are very, very flexible. And at the same time, if we want to, for instance, record with lasers rather than with the electrode, we can put our materials inside of a chamber like this. So what you see over here, there is a chip that we fabricate in the clean room, and we add our nanoscale materials there. And then you can see we connect it to the PCB board, and with this PCB board, we can easily access them with electrical connection. But what we can also do is that we can access them through optical connection, because as you can see over here, there is a little window, so we can shine the lasers through this window. But you might be wondering why there is this ugly white thing standing there. Well, it's there for a reason, actually. This is because if you want to create a biointerface, for example, you need to create a house for your little cells that go inside of this well. So what we do in the end, we sprinkle all our nice cells of interest, and quite often we use either cardiac cells or we use neural cells, and then we put them right inside of this chamber over here. And that's why this chamber also has this little cap on top. And we put this little cap on top, and we put all of this in the little house for the cells, which is called incubator. And in this way, we create an interface to the living system. And so we can study what's happening at the nanobio interface and how the new interesting properties of these nanomaterials can be used to stimulate neural activity, for example, or to record what the cells are doing on the surface. And this type of direction in general as nanotechnology, it has enormous applications in industry as well. So for instance, if you work on studying nanomaterials, you can easily transition into nanoelectronics companies or any electronics company for this matter. This includes Intel, Applied Materials, NTT, and many more actually, because I'm only naming a few. And of course, if you're interested in joining companies that are using neural interfaces such as like Neuralink or Precision, this is where this type of work is directly relevant again, because we fabricate those in our clean room again, and this is all done on large scale, on wafers, pretty much the same as the company is doing.
It's obvious that we are very, very fortunate you are here with us, not only as an instructor, but as a researcher as well. I know in our conversations and getting to know each other, you were just very excited about being here at UCF. Could you maybe tell our students why you are so motivated that you are now UCF faculty?
Well, I think our school is truly extraordinary. Why? Well, there are a lot of reasons, really a lot, and I probably can spend an hour talking about them, but I'll try to be short. For me personally, I find this place an incredible opportunity to help you guys. Why? Well, myself, I come from a small city, literally in the middle of nowhere in my country, so I know what it's like to find your path through. So I really hope that I can help you as well to find your path here. And I think UCF is one of the best places to be at, because we have all of these wonderful departments in one place, and it's all located next to each other, so you can truly find yourself. And I think the spirit of the school just really promotes your vision, because you have to reach for the stars. You really have to. And I'm not joking about it. You have to start your dream journal. You have to start thinking big, because it's your life and you can really achieve incredible things. And on the top of that, we have absolutely fascinating systems and all of the facilities nearby, because we have a very strong engineering school. We have beautiful optics institute. And then we have an absolutely stunning school of medicine. And as a result, you can do very good research here as well. And you can learn interdisciplinary science. But the gold is our faculty members, really. Everyone is so nice and so friendly and so collaborative together. So I'm sure that here you will really enjoy your time. And most of all, you can find yourself and understand what you want and who you want to be.
Hello, everyone again. So this is Research 1 building, the actual house of Advanced Materials Characterization Center. Welcome in, welcome in. This is where we find out what our materials or our devices look like. What do we do here? Well, primarily device characterization after we fabricate it in the clean room, because we don't know if it worked or not. But we also check what the materials are like, because we have a lot of other type of detectors here. For example, Raman spectroscopy right over here. But today we really want to show you scanning electron microscope, because this one is a workhorse for all of our devices. Come on in.
Hi, I'm Mark Martino, PhD student in optics and materials here at UCF. This is a scanning electron microscope. Fantastic and canonical tool for investigating structural features that are submicron. This is an example of such submicron features. On the screen, you can see an array of square holes that is for a functional optical design, specifically a nanofabricated structure tuned to absorb a specific frequency of midwave infrared light.
Hi everyone, my name is Francisco Hernandez. I'm a PhD student in optics and material science. So I'd like to show you today it's interesting structure I've been working on for this past year. Essentially, I'm a student that works with a lot of semiconductors. It's a big growing industry, especially now these modern days where people always talk about these chips, all these fancy computers, fast systems going on. So I wanted like to do today is like create a sample using like two common materials like lead selenide and gallium arsenide. And I stacked them together using a very like cool instrument. It's called like a molecular beam epitaxy, or MB for short. MB is like a pretty really like an interesting equipment. Like it's almost like important for like semiconductor like growth and like just like device building. Essentially what MB is, it's like a technique where you spray paint atoms in such a way where like it's very controlled, so you can make very like high quality materials like what a thickness you want and like in terms of like very purity. So we did that. We grew like specific like thicknesses, and then using clean room techniques, we wanted like just create these nano hole arrays, which involves like patterning using like photoresist and using like lithography techniques to create like these array of like square holes.
I'm Nicholas McNeil. I'm an electrical engineer and I'm a junior.
I'm Alex Miller. I'm a materials science and engineering major, and I'm a senior.
My name's Malia Insingram. I'm a computer engineering major, and I'm also a senior.
My name is Christian Turner. I'm an electrical engineering major, and I'm a junior.
My name's Cade Woods, and I'm an electrical engineering major, and I'm a junior. We are the Clean Room Fellows. Now let's get to know the Clean Room Fellows more. All right. Now you might be wondering why I'm gowned up in this. So these are my booties. These are to prevent any contamination from the outside environment on my shoes from getting inside the clean room. Down below, you can kind of see the mats that we use to also keep any dirt off our shoes in the environment. Our next part would be our gowns. So our gowns is meant to not only protect the devices from you, from anything on your clothing, any dirt and debris, but also it does serve, not meant to, it serves as a little layer between you and the chemicals that you use within the clean room environment. The next part would be my gloves. The gloves we use for solvents, acids, vice versa. Typically one glove for dealing with solvents, just to prevent any of it from getting in my skin or on my clothes. We double glove for handling acids. That's to prevent any corrosives or anything from getting on your skin or within any of the layers between you. Next will be my mask and my overall hairnet. Both of these prevent, again, debris or any little particles from coming out of my hair, dirt, vice versa, or anything in my breath. Maybe I ate at Arby's beforehand, from getting into the nanochips I'm working with. Next will be my goggles. My goggles are meant to protect my eyes from any of the chemicals I'm dealing with, any splashback, anything that might be stuck within my eyelashes, vice versa. Now that you've seen my fit, you might be wondering how I ended up in the clean room. The CACS department usually sends out emails regarding opportunities available within the department, internships, or anything through external companies. I recently received an email my freshman year from Ashley Duprat. They had an opportunity orchestrated through Dr. Avra. They were hiring for a UCF co-op, which is where you go inside the clean room, work with some of the machinery here. Between your classes, they work within your schedule, get to learn the machines, how to use them, what process they're involved with, and overall just get an overall taste of what is involved with the semiconductor industry. Previously, at least for me, I had no idea what a clean room was. So getting the opportunity to come in here and learn how to use these machines, how each is so involved with the process of making a chip, was a really important opportunity to me. And they are offering more. Just keep a lookout within your email. All right, now let's talk to Nick.
Hey freshmen, like I just said, my name is Nicholas and I'm a Northrop Grumman Fellow. So you're probably wondering what a fellowship is and why you hear it so often. So a fellowship is basically a company funding your research at UCF and for the opportunity for you to later get an internship at that company. So if I'm successful and I get my internship this summer, I'll be interning at the Apopka facility doing advanced micro device packaging for Northrop Grumman. So the way that I got my opportunity to be a fellow is through Dr. Mike at the Draco Lab. I did research with him for a year and I eventually just put forward my name and surprisingly I got it. I can't emphasize enough just how important undergraduate research is to developing you and your career. It helps you learn the different skills that are necessary for your industry and just interacting with the smartest people you'll ever meet. Now, that's enough about me. Let's cut to Alex.
Hi, I'm Alex. I am an Intel fellow here with the clean rooms. I've been working here for 3 years now, and I work mainly with a lot of our characterization equipment like the scanning electron microscope. We have an optical profiler, and we use that to closely examine the microscale features that we pattern onto the wafers we make here. Let's go talk to Malia more about what she does in the clean room.
Hi, my name is Malia again. I'm an Intel scholar here at the clean room. I've been working here about 2 years now, so I first learned about this position mainly through the CECS email from Dr. Reza, and I was mainly interested on what the clean room is all about, and also semiconductor manufacturing, how are chips manufactured essentially. And some of the work I do here, I mainly train the PhD and graduate students on different processes relating to their research. So I also work on some of the lithography machines. So we use lasers to kind of etch patterns onto the wafer. And also I work on the furnaces, also the rapid thermal annealer, which also works with like metal deposition and working with fabricating various chips. And now I'm gonna pass it off to Christian. He'll give you a whole layout on what we're all about.
And here Cade and I are loading the wafer into the PECVD system to dep an oxide layer on the substrate. That purple color is the plasma that's enhancing the deposition process to get a nice even oxide layer. Here we are unloading the wafer. And you can kind of see that rainbowing color, that's the thickness of the substrate, the oxide on top of the substrate, and there's the measurement using the ellipsometer. And here we are spin coating a layer of photoresist on top. This chemical is reactive to light and what we use primarily to pattern our substrates in semiconductor manufacturing. So here's Malia putting on an even coating of that red liquid, that's the photoresist. And we have to use a yellow room because the wavelength of normal white light will react with it preemptively. So we want to make sure we react the right spots at the right time. Here we are spinning it off to get a nice even coating. We're aiming for, I think it's about 1 micron with this resist. You can manufacture different thicknesses, and we're baking all the solvents out to get a hardened layer ready for lithography. So this is our mask aligner. We put it in there with a mask to filter out the light that we don't want and pass through the light that we do, reacting onto the substrate. The substrate's resist layer, and throwing it in the developer liquid will wash away the more soluble areas that were exposed to light. So we can kind of see these streaks of red liquid. Those are the parts of the resist that are washing off. And if we zoom in closer, we can see under that reflection, you can see that pattern. Now we're going to throw it under the laser microscope and show that pattern up close so we can see. So this microscope works off laser and camera reflection, I believe, and it can measure the resist coating thickness using laser and optics technologies. And here we go. This is the Pegasus that we depped on there and pattern the resist into with a smart mask.
Hi, my name is Erin Asher, and I graduated from UCF with my bachelor's in materials science and engineering. While I was at UCF, I did undergraduate research where I validated the capability of a lab-built centrifugal force spinner. Now, I work in Durham, North Carolina at a company called Wolfspeed. We do semiconductor manufacturing, and I work as a process engineer in epitaxy if you want to look it up. Process engineering is keeping track of our product quality while also doing projects on increasing efficiency and capability. My biggest advice is to try everything you can while you're in college, because you never know what you may end up liking that you wouldn't have tried before. I thought I was going to do biomaterials, but by working at this job in a semiconductor manufacturing facility, I've learned that I love doing it, and I'm excited to grow my career there.
Hi, my name is Alec, and today I'm going to be talking about Material Advantage. Material Advantage is basically the student program for material science and engineering. It's the equivalent of like the Society of Civil Engineers, but for materials engineers. So first of all, what is materials engineering? So materials engineering is the study of how materials behave. So whenever we're designing a plane, as you see in the image, we got to take into account what stresses it's going to experience while in the air, while landing, what the engine is, how hot the engine's going to be. And based off of those parameters, we test different materials, different composites to see what will be the cheapest and most reliable. So there's different classifications of materials. We have metals, ceramics, polymers, composites, and all of them have their own separate important purposes, and they're all chosen very specifically for a certain reason. For example, you're not going to design an engine out of a plastic or a polymer. You're going to choose a metal because it can withstand those high temperatures. And then since we know that they can withstand those high temperatures, we look at the structure, we look at what properties cause that to happen, and then we further enhance our design. So now, material advantage. So material advantage is it's only $20 to join, $30 to join a year, and it gives you access to scholarships, monthly journals, and you can learn more about different materials, about what the industry is doing, and it also connects you to other students that are interested in material advantage, other faculty, and alumni. And yeah, that's a quick short summary of what is material advantage. You should consider joining. We have social events, we have GBMs, we have guest speakers, and if you want to further your engineering knowledge, material science is the way to go. So if you would like, scan this QR code to go into the material advantage link. And back here, this is our Night Connect. And then we also have a Discord, which it should be linked in the Night Connect. Thank you.
Hi guys, I'm Alex. I'm an electrical engineer in my senior year of school. Last year, of course, you guys saw me before. I was over studying abroad in England, which is funny, of course, because I'm unironically half English. While I was over there, I visited some of the famous cities in England, such as Oxford and Cambridge. And in addition, I also went around to different places in Europe, such as Germany, Scotland, over in the British Isles, Belgium, and what was the last one? Oh, and the Netherlands. If I have some advice for you guys, I would recommend going over to join clubs and join projects this year as early as you can. That way you can get your internships early on in your engineering career.
Hi everyone, welcome to Go for Launch with the GTAs, sponsored by the Space Game this week. Hope you like our jerseys. This week in lecture, you learned about the Material Science Department and what they have to offer. You got to tour one of the labs over in Research 1, as well as the clean room over here in Engineering 1, hear from an awesome alumni, and learn about Material Advantage, one of the clubs in material science.
And now we're going to go into what the lab is going to look like for the next 2 weeks. So, 2 big reminders for my Friday classes. After 3 p.m., you're going to be canceled due to the game. And you're going to have the ability to rent out reserved robots. Same with my Tuesday labs. Since lab is canceled next Tuesday due to Veterans Day, you're able to use the sign-up details in your announcement. Sign up for these designated reserved robots that are in the TI lab, and you can use them in the track that's right there behind us. If you're not in those 2 labs, though, do not fret. There are a total of 10 robots in the lab now as of Thursday. And you guys can rent them out in the TI lab. All you have to do is turn in your student ID. They're going to mark which robot you take so that we can do inventory and make sure that you return all the robots, the cables, and the ducts that are in the boxes. We're going to look for all 3 components when you're turning them back in, and then you'll get your UCF student ID back. But you're going to have about an hour to practice with these robots, and just be courteous of your time because there are 2,000 of you in total, and we want to make sure everyone can get a robot so you guys are good to go for your final competition, which, what's the deal with that?
So, final competition is the week of November 17th. You will do that during your lab time. As a reminder, you have a 10-minute run for your challenge. You get a little bit of practice time, not much, because we want you to get running. So, come to lab prepared with your launcher and your code. All should be ready to go. Basically, all you need to do is upload that code to your robot, do a test run, make sure it's calibrated and works properly, and then you are good to go through that challenge. Please remember to review the rules and make sure that you're aware of any penalties due to hitting obstacles or having to pick up your robot. We'll go through a little bit more of those next week, but keep those in mind.
Absolutely, and just keep up for your announcements. We're going to be posting any relevant information over there, so keep posted there.
Yep. And then in terms of lecture, this is your third to last lecture for this semester. So this wraps up all of the departments that we are focusing on this semester. And then we have 2 more lectures coming up that will be wrapping up before Thanksgiving. So, lucky for you guys are done with this course before you go to Thanksgiving. You get to enjoy that nice turkey dinner if that's how you celebrate, and then you get to come back for finals, which, boo, finals. But such is life as a college student. And with that, hope you guys have a great rest of your day. Happy space game.
See you there, maybe.
And well, maybe see you there. And here's your quiz code.